Now, graphing hyperbola is not centered at the origin. Graphing hyperbola is centered at a point hk other than the origin is similar to graphing ellipses centered at a point other than the origin. We use the standard form when x is a positive term for horizontal hyperbolas, and then we use the standard form for when y is the positive term for vertical hyperbolas. And from these standard form equations, we can easily calculate and plot the key features of the graph, the coordinates of its center, vertices, co-vertices, and foci, the equations of its asymptotes, and the positions of the transverse and conjugate axis. Now, given a general form for a hyperbola centered at hk, we're going to sketch the graph. Number 1, we determine which of the standard form applies to the given equation. Convert the general form to that standard form. Step 2, we're going to use the standard form identified in Step 1 to determine the position of the transverse axis, coordinates for the center, vertices, co-vertices, foci, and equations for the asymptotes. Now, if the equation is in the form when x is the positive term, then the transverse axis is parallel to the x-axis. The center is hk. The coordinates of the vertices are h plus or minus a, k. The coordinates of the co-vertices are h, k plus or minus b. The coordinates of the foci are h plus or minus c, k. And the equations of the asymptotes are y, which is equal to b plus or minus b over a times x minus h plus k. Now, if the equation is in the form where y is the positive term, then the transverse axis is parallel to the y-axis. The center is at hk. The coordinates of the vertices are h, k plus or minus a. The coordinates of the co-vertices are h plus or minus bk. The coordinates of the foci are h, k plus or minus c. And the equations of the asymptotes are y is equal to plus or minus a over b times x minus h plus k. Step number 3, we're going to solve for the coordinates of the foci using the equation c, which is equal to plus or minus the square root of a squared plus b squared. Number 4, we're going to plot the center, vertices, co-vertices, foci, and asymptotes in the coordinate plane and draw a smooth curve to form the hyperbola. So in example number 5, we're going to graph the hyperbola centered at hk given by the equation 9x squared minus 4y squared minus 36x minus 40y minus 388, which is equal to 0. We're going to identify and label the center, vertices, co-vertices, foci, and asymptotes. So, first thing we want to do is that we have our form, and we want to be able to group them. So we're going to group our x terms, and we're going to group our y terms. So we have 9x squared minus 36x, and then we have minus 4y squared minus 40y, which is equal to 388. And so here, what we notice is that if we factor out the 9, we get x squared minus 4x. And over here, we're going to factor out a negative 4 to get y squared plus 10y, and that's equal to 388. So what that means is that our y term is going to be negative, and our x term is going to be positive. So again, factoring leading coefficient gives us the following. So we get 9x squared minus 4x minus 4 times y squared plus 10y equals 388. And then we're going to complete the square twice. Now remember, to balance the equation by adding the same constants to each side. So over here, we're going to add an n, we're going to add an m, and on the right side, it's going to be 9 times n, and on the right side, we also have minus 4 times m. So that sign is very important to include with the 4. So, completing the square, n is equal to 1/2 of b, which is negative 4. Half of negative 4 is negative 2. When you square that, it gives you positive 4. For m, we're going to take half of b, which is positive 10. Half of 10 is 5. When we square that, we get 25. So now filling in n and m, we have 9 times x squared minus 4x plus 4, minus 4 times y squared plus 10y plus 25, which is equal to 388 plus 9 times 4 minus 4 times 25. So on the left side, it remains the same. On the right side, we're just doing our multiplication. So 38 plus 9 times 4, which is 36, minus 4 times 25, which is 100. So if we combine all that, we're going to get 324, and then we're going to rewrite these as perfect squares. So we have 9 times x minus 2 squared minus 4 times y plus 5 squared. Now we're going to divide both sides by the constant term, which is 324, And if we divide both sides by 324, we get x minus 2 squared over 36 minus y plus 5 squared over 81, which is equal to 1. Now, the standard form that applies to the given equation is x minus h squared over a squared minus y minus k squared over b squared, which is equal to 1, where a squared is equal to 36, b squared is equal to 81, or a is equal to 6, and b is equal to 9. Thus, the transverse axis is parallel to the x-axis. So, the center of the hyperbola at hk is 2, negative 5. The coordinates of the vertices are going to be 2 plus or minus 6, negative 5. So we get negative 4, negative 5, and 8, negative 5. The coordinates of the co-vertices are going to be 2, negative 5, plus or minus 9. So we have 2, negative 14, and 2, 4. The coordinates of the foci, where c is equal to plus or minus the square root of a squared plus b squared, is 36 plus 81. So plus or minus the square root of 117 equals plus or minus 3 times the square root of 13. So the coordinates of the foci are 2 minus the square root of 13, negative 5, and 2 plus 3 times the square root of 13, negative 5. And then the equations of the asymptotes are going to be the following. Y is equal to plus or minus b over a times x minus h plus k. So that's going to equal plus or minus 3 over 2 times x minus 2 minus 5. Next, we're going to plot and label the center, vertices, co-vertices, foci, and asymptotes, and draw smooth curves to form the hyperbola as shown in figure 9. So here we have our vertices. So we have negative 4, negative 5, and 8, negative 5. Our co-vertices are 2, 4, 2, negative 14. Our center is located at 2, negative 5. And so drawing our rectangle, we can then draw the corners of, so what I mean by that is, let me show you the rectangle. So we have our rectangle here. And so that rectangle allows us to be able to then draw the asymptotes. So the asymptotes are then y is equal to 3 over 2 x minus 2 minus 5, I believe. So that should be minus 5. And then over here, it's y is equal to negative 3 over 2 times x minus 2 minus